Today we're going to continue looking at sections 3.2 and 7.2. So today we are going to be proving triangles congruent using 4 postulates. So when it says we're going to be proving, that means that we are going to be creating 2-column proofs. So what is going to be crucial with these 2-column proofs is that you have a picture sketched. So always make sure that you draw a picture when you are doing your homework problems and when you're taking quizzes and tests, because you are going to be required to mark up your picture. Okay, what we're going to do is we are going to have 2 columns, one where we're talking about statements and one where we're justifying those statements with our reasons. We'll always number our steps, and we will verify by looking at our picture and looking at our steps throughout the proof that we have the correct answer. So we are given that the ray PR and the ray PS trisect the segment QT. So that's my first statement. And my reason, when I number that step, it is given information. Okay, well, notice that that given information contains a vocabulary word. So I am not going to move on to my next given until I expand on that vocab. So the fact that we're talking about trisect means that we're dividing into 3 equal pieces. If we are looking at a segment, well, that means that we have 3 congruent segments. So notice that the segment QT is down at the bottom. If I look at the smaller segments, that looks like it's QR, RS, and ST. Now, it is going to be important that we name these correctly. So QR is congruent to RS, which is congruent. Now, notice that what I'm trying to prove is that the triangle PQR is congruent to the triangle PST. Notice that I put Q and R first. So Q is in the middle, R is last. Notice that over here, we have then T and then S. So I want to make sure that I say segment TS, not segment ST. My reason, though, is an if-then sentence. So remember, it's a broad sentence justifying this conclusion that we just came up with in step number 2. So if 2 rays trisect a segment, then it divides the segments into 3 congruent segments. Okay, I already marked it in my picture, but once again, the if part is what was given. We were given that 2 rays trisected a segment. Then is what we were concluding. Well, in that statement number 2, we have then 3 congruent segments. All right, we're not going to be able to expand off of that any further. So I can now go back to my given. My next given is that the segment PQ is congruent to the segment PT. Once again, that is given information, and I'm going to mark it in my picture. I'm going to have to mark it differently, so I'm going to give it 2 tick marks. I can't expand on that any further, so my 4th step is my last given, that the segment PR is congruent to the segment PS. Okay, once again, I have to mark that different. All right, so we've run out of givens. We can't expand on any of those givens. Notice that what we're trying to prove is that we have 2 congruent triangles. So there's definitely more than 2 triangles in this picture. I'm going to highlight the triangles we're talking about. We're talking about the triangle PQR, and we're talking about the triangle of PTS. So it's these 2 outer triangles here. Well, if we're thinking about all the ways in which we could prove congruent triangles, we've got side, 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 angle, side, angle, and angle, angle, side. We are trying to get one of those. Hopefully we notice that with the triangles that I have highlighted, we have 3 sets of sides that are marked congruent. So we do have enough information to go to our conclusion. So our 5th and final step is that the triangle PQR is congruent to the triangle PTS. So now I need to know, well, what's my reason? Well, if it's all the sides, that's because of side, side, side. But now I want to go back and justify, yeah, I have it marked in my picture, but sometimes people mark things prematurely in their picture and forget to write it down in their proof. So we have to go back through our proof, find where we have our 3 sets of congruent segments. Notice that step number 2 contains segments that are in my triangles that are marked. So that is my first one. Notice step number 1 didn't say anything with congruent, which is why I had to ignore that. Notice that it looks like step number 3 and step number 4 were the other 2 spots where we had congruent segments. Like I said, because we're trying to prove congruent triangles, and that was what we have in step number 5, we are now done. So let's look at this next example. Once again, sketching a picture is going to be crucial because we're going to be marking up the picture and helping that justify our proof. So go ahead and draw it. We once again have to determine what our statements and what our reasons are for this 2-column proof. So I'm going to start with my first and only given, that the segment AC bisects angle BAD and angle BCD. That is given information. Okay, that in itself, we're not going to be able to mark, but because it has that vocab word bisect, I know that I'm going to be able to expand on that. Remember, to bisect means to divide into 2 congruent pieces. The first thing that I see is that it's bisecting the angle BAD. So that's this highlighted yellow angle. Well, if it's dividing that into 2 congruent pieces, hopefully we know that the vertex is A. I need to name 2 smaller congruent angle A's. Well, that would be angle BAC, congruent to the angle. Now, notice how I put B first. If I'm looking at the triangles that I'm trying to prove congruent, B is in the middle. Notice that on the other triangle, D is in the middle. So I have to start with D, so DAC. So those 2 angles are congruent. We need to justify this with a reason. So we have to come up with an if-then sentence. So what did we talk about? Well, if a segment bisects an angle, okay, that's the if part because that's what's given to us, then it divides the angle into 2 congruent angles. That's what I was concluding in step number 2. And now I'm going to mark my picture. Okay, I can't expand on step number 2 any further. However, if we notice, there wasn't just one angle that's being bisected. I have another angle. So that was this angle, BCD. Notice that. That means that at the vertex of C, we're going to be able to divide that angle into 2 smaller congruent angles. So if we look, that would be angle BCA congruent. Once again, if I start with B, and that's in the middle of the triangle that I'm trying to prove congruent, D is in the middle, so I have to say angle DCA. Well, notice that those 2 angles I got congruent because of the same reasons as the fact that it was bisecting an angle. So because if a segment bisects an angle, then it divides the angle into 2 congruent angles. If that's the exact same thing, we don't have to rewrite that twice. We can just say same as 2. And that's why it's important to number your steps so we don't have to repeat ourselves and I know exactly what step I need to go back and look at. And then I can mark that in my picture. Notice that I have to mark these differently than the angle A's that I marked because I don't know that all 4 are congruent. I can't expand on that any further. It looks like there are no more givens, so I can't do anything there. I want to try to prove that the triangle ABC, so let me highlight that in green for us. So this triangle right here, ABC, is congruent to the triangle. Let me highlight that in, let's say purple. Okay, so we want to get these 2 triangles to be congruent. Well, if you look at the markings, right now I only see two things that are marked in my triangles. I want to try to prove them congruent by either side, 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 angle, side, angle, or angle, angle, side. Because what I already have in my picture are two angles, hopefully we notice that I can't have side, 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 and I can't have side, angle, side. So it's between angle, side, angle, or angle, angle, side. Based off of my picture, what do I notice? Well, I notice that the two triangles are connected. They're connected with the segment AC. So remember, a segment can always be congruent to itself. So if I say segment AC is congruent to itself, if I look at the letters of my triangles that I'm trying to prove, A is first, C is last. Well, same thing here. A is first and C is last. So I get to keep them the same there. How are two segments that are the same congruent to each other? Well, remember, that's because of the reflexive property. And then I can mark that in my picture. And hopefully now we notice that, hey, now I have three things that are marked in my picture. It looks like the side was in between the angles. So that means we want angle, side, angle. So I have enough to prove that the triangle ABC is congruent to the triangle of ADC by angle, side, angle. And once again, now I have to go back through my proof and find where those steps were. So where was my first set of congruent angles in the triangle? Well, that came from step number 2. Then I want the sides. Well, where did I have congruent sides? That came from step number 4. Where did I have my other set of congruent angles? That came from step number 3. So there is my proof. All right, sketch this next picture. And then once again, we're trying to come up with our statements and our reasons that justify those statements. So numbering my steps, start with the first given. I know that the segment AB is congruent to the segment EF because that is given information. And I'm going to mark that in my picture. So AB and EF, I'm given one tick mark each. Can't expand on that any further, so I move on to the next given. I'm told that the segment BD is congruent to the segment CF because that is given. So marking that, BD is this. I'm going to give it a circle there. CF is this. All right. Can't expand on that any further. So moving on, we have that the segment AC is congruent to the segment ED. That is given. AC, I'm going to give that 2 tick marks. ED, I'm going to give that 2 tick marks. I can't expand on that any further. Notice that what I'm trying to prove is that the triangle ABC, so if I look, this triangle right here is congruent to the triangle of EFD right here. So these two side triangles. So once again, we're looking for, do I have side, 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 angle, side, angle, or angle, angle, side? Notice that while I have 3 different segments that are given to us, I hope you are aware that we don't quite have congruent triangles yet, because not every single side relates to the triangles that I highlighted. Notice that BD and CF are 2 segments that are bigger than the triangles. So that's a problem. I can't just say my 4th step is what I'm trying to prove. But because I can then see that those two actually overlap, if we look at where those two overlap, notice that they overlap right here with that smaller segment of CD. What happens if I was to take away what overlaps? Hopefully you notice that we would end up then with the 2 segments that are a part of the triangles that we're trying to prove congruent. Well, how do you go from something big to something small? That's subtraction. So we are able to say that the segment of BC is congruent. So now if I did B was in the middle, C is last, I have to go over the other triangle. I want F first, followed by D. So those two are going to be congruent, And that's because of this subtraction property. And then I'm going to verify it. So remember, subtraction means you start big. Well, it was what was given to us. We have segment BD. That was the big thing. What did we want to take away? We wanted to take away what they had in common, which was CD. If I do that, that leaves me with the segment of BC. On the other side, what did I start with? Well, the big piece was the segment of CF. What did I take away? I took away what they had in common, which is CD. When I subtract those, it leaves me with the segment of FD. Now I can mark that in my picture. Those two are congruent. And now if we look, we've got all three segments. So that means no angles here. We can now prove that the triangle of ABC is congruent to the triangle of EFD. And this is because of side, side, side. Now, looking back at my statements, there's 4 sets of segments. So we have to really pinpoint which ones went with the triangle. So A, B, and E, F, those were definitely sides of my triangle. So step number 1 is good. Step number 2, B, D, and C, F. Well, remember, those were segments that were bigger than the triangle. So I do not want to say step number 2. Step number 3, of AC and ED. Those are sides of my triangle. So that got me my congruent triangles. And then the 4th step with the subtraction allowed us to get that 3rd and final side. All right, if we look at this one, once again, sketch the picture. We are given that the segment of GH is congruent to the segments KJ. That is given. And I'm going to mark that in my picture. So GH, KJ, going to mark that with 1 tick mark. Then I have the angle G congruent to the angle of K, also given. And I'm going to mark that in my picture. Can't expand on that. Moving on to our 3rd and final given, that the segment of NG is congruent to the segment of MK, because that is given. And we'll mark that. NG gets 2 tick marks, so does MK. All right, we're trying to prove that the triangle, oops, that's not what I wanted. The triangle of NGJ, so I want this one congruent to the triangle of MKH. So if I look at my markings, I hope we are okay with seeing that while I see 3 markings, not every single marking actually corresponds to the full set of the triangles that we highlighted. Notice that the very first given said GH. GH is not that entire side. The entire side is going to be GJ. So we have a problem. Same thing here. KJ is not the entire side. I need this whole entire side of KH. Well, how do I make that happen? Well, notice that what I highlighted, they share something in common. They share the segment of HJ. So if I start with something small and I want to try to prove something bigger, I hope we're okay with the fact that we want to do addition. So my 4th step, we can say that the segment of GJ is congruent to the segment of KH, and this is the addition property, and we'll verify it with our segments that we show that we add together. So notice that GH was a small segment. I'm adding on that overlapping piece of HJ. Put them together, there's my GJ. Started with the segment of KJ. I want to add on a piece. I'm adding on that overlapping segment of HJ. Well, put those 2 together, you got KH. All right, so now that I have that, looking at the markings, I do have 3 sets of things marked in my picture. So I have enough to prove that the triangle NGJ is congruent to the triangle of MKH. Notice that we've got a side, an angle, and another side. So side, angle, side. So where was my first set of congruent sides dealing with the triangles? Well, remember, step number 1 was not a full side of the triangle, so I'm not going to say that. If I look down at step number 3, there I see a segment, and that segment is a segment in the triangle. So step 3 is my first step. Then I want the angle. Well, where do I have my congruent angles for the triangle? That came from step number 2. Step number 4 with the addition got me my other set of sides. And there's my proof. All right, so that's us proving triangles congruent using those 4